Today we start with lecture 11 of Mat 303. We start with 21 as per my notes. Entire function is analytic function. Analytic means differentiable. Analytic at each point in complex plane. Here we restrict ourselves up to the complex plane. So this is a definition, and now we are going further. In 22, if f dash z equal to 0, what is f dash z? Ux plus ibx equal to 0. Now by formulae in the CR equation, or we derive the formulae in the derived equation, this value equal to minus Vy minus Iuy equal to 0. And though we find Ux equal to Vy and Uy equal to minus Vx, or Vx equal to minus Uy, as both of these are equal to 0, I have Ux and Uy are 0, Vx and Vy equal to 0, means U constant, V constant, and therefore Fz equal to U plus Iv is constant. That we wanted to prove in 22. As this is online lecture, I am not pausing for a few minutes. You may pause this video for a few minutes and going further after understanding the statement and the proof. In 25, Fz equal to U plus Iv, which is analytic, as well as its complex conjugate, means U plus Iv bar is U minus Iv. Both of these are analytic in some certain domain B. Then Ux equal to Vy and Uy equal to minus Vx. On that side, if I say this is equal to U plus capital U plus Iv, that means that capital U is small u, capital V is minus V, Ux is Vy, means Ux is equal to minus Vy, and Uy is minus Vx, and therefore Uy equal to small vx. If you compare both these values, Vx of negative side, Vx of positive side, both are equal, and therefore Vx is 0. See here. That means that minus Vx equal to Vx, and therefore Vx equal to 2Vx equal to 0. Vx equal to 0. Similarly, Vy equal to 0. Similarly, Vx equal to 0. Similarly, Vy equal to 0. That means that U and V both are constant, and therefore Fz is constant. That we wanted to prove. Now there is one definition. Now there is one more definition of harmonic function. Means if you differentiate twice with respect to x to some function and twice with respect to y to that function, and if you do the addition of that, if it is equal to 0, we say that this function capital H is harmonic function, and this equation is also known as Laplace's equation. Now here, whenever analytic function is there, we have Ux is Vy and Uy is minus Vx. Now if we apply differentiation with respect to x to both these sides, then this is U of xy, xx equal to vxy, and U of yy is minus vxy. Now recall the theorem which we have already proved in SYDSC, Schwarz and Young's. If you apply that here, means V of yx and V of xy both are same, as they are in opposite in sign. Their addition is equal to 0, and if we add both of them, we have uxx plus uyy is 0. Yes, it is. Uxx, uyy equal to 0. Means u is harmonic function. Now, if I cancel out this x and this y, and if I give this sign of minus to this one on other side, and I apply y over both this side, x over both this side, and then again apply the same and adding both of them, what we will have, that we have vxx vyy equal to 0. That means that v is harmonic function. So whenever a function v is of this type, u is of this type, we call they satisfy CR equation, and we call v as harmonic conjugate of u. We call v as harmonic conjugate of u, and that is definition of 30. And this theorem which I have proved, this is 28, not 27, sorry, this is 28. What is harmonic? Twice by x, twice by y differentiate. Addition is 0, we call it harmonic function. If they satisfy CR equation, both of them are harmonic functions. And one more definition which I have applied just, which I told you just before this, is that V is harmonic conjugate of Q. Now we have to understand something is there. Whenever we differentiate with respect to x, y is constant. Again, what I said, whenever you differentiate with respect to x, y is constant. Whenever you differentiate with respect to y, x is constant. I repeat the whole statement again. Whenever you differentiate with respect to x, y is constant. Whenever you differentiate with respect to y, x is constant. So, if we use the same idea for integration, what we will have? If we integrate with respect to x, then the constant term should be of y. And if we integrate with respect to y, constant term should be of x. Keep in mind. U equal to y cube minus 3x square y. U is given. CR equations are already satisfied. That we have in mind. And we wanted to find small b. So we start with ux is minus 6xy, and that is equal to v of y. Now here what we are doing, u is y cube minus 3x square y, and ux equal to minus 6xy. Y is differentiation of y with respect to x is 0. Minus 3y constant, but that of x square is 2x, and therefore minus 6xy. Ux is vy, and therefore minus 6xy is there, and this value of v of y. Now we integrate this with respect to y, and therefore constant term should be of x. Minus 6x constant, and the integration of y with respect to y is y square by 2, and though it is minus 3xy square, and constant term, that is phi x. I say this as equation number 1. Then v of x. What is v of x? Differentiation of v with respect to x is minus 3y square, and x to x will be 1, and then differentiation of phi x is phi dash x, and vx equal to minus uy. So what is it? 3y square minus 3x square. So compare both of them. Phi dash x is 3x square, but we wanted to find phi x, and therefore three is constant, x cube by 3, so this is x cube and plus c, that is constant of integration. So what is v? How it is? Minus 3xy square and phi x. V is minus 3xy square plus phi x, that is x cube plus c, and this is v. But we don't want to stop here. I wanted to find something more in this one, and that is fz. That is u plus iv. U, that is y cube minus 3x square y plus I minus 3xy square plus x cube plus k. Actually there is c. But if you multiply it with I, it will be IC, means some another constant, and I say that is k, and therefore it is not in a calculation right now. So this is equal to y cube minus 3x square y minus 3xi y square I x cube plus k. Can I write this as like this one? I raised to 4 y cube plus 3 I x square plus 3 x I y cube plus I x cube plus k. Then I took I in common. How it is? I explain you. I square is minus 1. I raised to 4 is I square into I square, so minus 1 square, and therefore it is square. So I write I raised to 4 means If I take I in common, so it is I cube y cube, this term. Then here it is minus, means it is I square like this. Now there is no sign of minus. Clear? So plus 3x square. One I is there, one I is outside. Plus this is I cube. This is cube and this is square. Plus I cube y square. Now I took one I outside and therefore plus 3x I y square. I is already there outside and therefore this is x cube plus a. So this is x cube plus 3x square iy plus 3x iy square plus I cube y cube. So this is equal to I x plus iy cube plus a, and therefore this is equal to I z cube plus a. So whenever they ask you in exam, find v and also fz in the form of z, so it is like this. Clear? Write it so many times, you will understand by heart. We start with 35. X square minus y square minus 2xy minus 2x plus 3y, find v. So example is like same as before, but the procedure is also like same as before. Therefore u of x is 2x minus 2y minus 2. Differentiation of x with respect to x is 2x, x square is 2x. This is 0. X to x is 1 minus 2y and minus 2. Ux is b1. Now integrate this with respect to y. So v equal to 2xy minus y square minus 2y plus 5x. Say this as equation number 1. Therefore, now we differentiate with respect to x. So this is 2y plus 5x. And this is minus of uy. So differentiate this with respect to y and taking the negative of that. So this is equal to minus 2y minus 2x plus 3. So this is equal to 2y. How it is? Just see it once more. Differentiation of x with respect to y is 0. That of y square is 2y, but minus sign is there, so it is minus 2y. That of y is 1 minus 2x. This is 0 and this is y to y is 1 and therefore plus 3. So this is equal to 2y 2x minus 3. So now if we compare both these equations, if we compare both of these equations, what we will have right now with this one, phi dash x equal to 2x minus 3, and therefore phi s is x square minus 3x plus c. Now we put this value of phi x in this equation. So we have value for v, and that is 2xy minus y square minus 2y plus x square minus 3x plus c. So this is value of v which we wanted actually. They have asked only up to values of v. But now we are going further in the same direction to find f of z. Therefore, f of z is u plus iv, and value of u is from here x square minus y square minus 2xy minus 2x plus 3y plus I 2xy minus y square minus 2y plus x square minus 3x plus some constant I say k. X square minus y square minus 2xy minus 2x plus 3y 2xy minus y square minus 2y plus x square minus 3x. Constant I say it is k. This is equal to x square plus 2ixy plus I square y square. Minus sign is there. Plus ix square plus I cube y square plus I square 2xy. See here, I square 2xy, I square y square, I square I cube y square, because one I is there, I x square. Clear? Now remaining terms minus 2x minus 2ix 2iy minus 3ix minus 3I square y plus. Let's see how it is. Minus 3I square y 3ix with negative sign. Now simplify. This is x plus iy square. Yes, it is. If I take I in common, x square, I square y square 2ixy, x plus iy square, minus 2 in common, x plus iy, minus 3i in common, x plus iy. So this is equal to z square plus iz square minus 2z minus 3iz plus k. This is the equation which we wanted actually in the form of z. So be patient. Whenever you are doing this type of sum, your sign of positive or negative should not be differ anyways. Your mind should be sharp at that time. You should not do any mistake at that time. Okay, with this I stop here. Thank you very much.